Staff we have here at the Central Research Foundation includes myself, Greg Tomkala, as an Applied Research Coordinator, our Research Scientist, Praveen Sapkota, our Research Assistant, Amy Volosachuk, and a summer student, Lucian Carlson this year. And this is the start of our 2026 staff tour, so let's get out there and see what we got. This is our winter wheat seeding date trial. So we actually planted this last fall. The purpose of this trial was to determine what the best seeding date is for winter wheat survivability. So you can see the earlier planted stuff is a lot more ripe and almost ready to combine, whereas the later planted stuff is still quite green and immature. And then the stuff on the ends, and you can even see some blank rows in there and even on the plots behind you, those were the winter wheat trials planted really, really late. Winter wheat and any of the fall or winter crops that we do plant, they have to emerge and get to a certain size before the winter actually hits. If they don't do that, or if they're too small before winter actually occurs, they will die off. They have to be an established crop in the fall time so they can actually survive. There's a reason behind that. It's called viviparity, and winter dormancy has to be broken. In order for these winter crops to actually reach the reproductive cycle, they have to endure a frost. If they don't do that, if you plant them in the spring, they don't endure frost in the spring, they will not actually produce grain. So that is a problem that we face, so they have to be planted into winter time. Because of our winter conditions out here, we can only grow a handful of winter crops. Actually, really 3 are the big ones. So this is winter wheat. We'll be heading to the fall rye next. That's another winter crop. There is fall triticale you can grow as well. Other portions of the world, they grow different versions of winter wheat. There are winter barleys out there. There's winter canola. There are winter dry peas. We can't grow a lot of those ones out here because they are not hardy enough to survive our winters. The general rule of thumb is that fall rye is the most hardy for surviving the winters. Number 2 is winter wheat, and then number 3 is winter triticale. After that, everything else doesn't really survive your average winter here in this Yorkton area. It would not do well. There are some farmers down right beside the Canada-US border that are playing with winter barley, winter canola, and winter peas. They are having various success with it. It's not great, but it's a work in progress. Any questions? Number 367, this is a pea oat intercrop that I think 6 agroarm sites are doing. Yeah, quite a few of them are doing it. Intercrop is one of the bigger pushes. A lot more intercrop testing has been pushed of recent in the last decade. But typically, because this is a forage crop, or this is a crop for a forage purpose, this has been around for about 20 years and it's getting to be more and more popular. The purpose behind having a forage crop or cereal intermixed with a pulse is you get a little bit higher tonnage per acre, but you get high protein with it because your pulses are providing a high protein boost into your forage mix already, which is more beneficial for your livestock, and you don't have to add supplemental protein into your silage blend at the end of the day because you're already growing it with it at the same time. The other flip side or upside to that is your pea being a legume will fix nitrogen, so you don't have to supply as much nitrogen as a fertilizer because the pea is doing that work for you at the same time. The other synergistic symbiotic effect is that the pea, being a viney crop with the tendrils here, will grip onto the oat so it doesn't fall down, so you can actually harvest it and capture the vast bulk of the crop here. The purpose behind this trial is seeing the difference between just standalone oats versus oats and peas mixed together at varying ratios, a 50-50 ratio, a 75-25 ratio of both peas and oats at the same time, to see which one has the best forage quality at the end of the day and best tonnage, and it will be sent away for a feed testing to see which one is the most ideal blend. And that can be recommendations passed on to livestock producers to say, hey, you should be doing your peas planted at this much pounds per acre mixed with either oats or barley. It could be about an equivalent exchange for oats and barley for that. This is all going, if we have a forage harvester, so we're just going to cut the whole plot and do a weight on it. And then the plot will be, I think this is being sent away as a green test, so that day I think this one has to get sent away and shipped to a lab for testing. Other times it would just have to be dried, and then we would do a dry weight test on it, and then we'd send away the dry sample for forage testing on it. The whole thing would be sent, the whole thing. But if I was a farmer or a producer, I would be cutting this probably in about another month's time, because you can just see the oat heads coming out on it right now. And even the peas, they don't have a lot of pods formed yet. And I would just silage the entire field. I'd probably swath it, and then the next day I'd go in there and forage harvest the whole thing. And then put it in a silage pile, and then put put the silage tarp on and let the anaerobic bacteria do its thing.
So the two would never be separate?
No, always together. And that's the point behind it, is to increase the protein level on it. Your barley is typically your standalone cereal for forage harvesting right now. Corn is the other one. Corn's really high in starch and high in tonnage. Barley is higher in protein and survives a lot better in different soil types. This gets you, the intercrop between peas and oats, gets you pretty good tonnage on it, and it gets you a high protein bump on it at the same time. So you're kind of meeting in the middle ground here and getting higher tonnage, and it's a lot lower cost than having to grow corn. Because with both oat seed and pea seed here, you're still probably 60% of the cost of growing a corn variety instead. Anyway, so this is canary seed. Saskatchewan is the #1 grower and exporter of canary seed worldwide. It is typically used as bird seed for canaries and other birds as well, but it is a high demand bird seed. It can be used as a low gluten feed or a low gluten flour stock for individuals that have gluten intolerance or celiacs. I'm not a huge fan of canary seed. Growing up, there's two types of canary seed. There's glaborious and non-glaborious. This is the non, because the ones that are glaborious, when you would take the seed off of the head, it had a hair on it back there. And this is about the itchiest product known to mankind if you ever combine this or have to ever shovel out a grain bin. It's like a thistle splinter when that hair comes off of the spikelet head, and it just stabs into your body nonstop. It is the most miserable thing to work with. So the non-glaborious types are great because they don't have that. It's been bred out of it. This crop looks really good. I'm actually stoked with how good it is and how clean it's looking because we did a lot of work for keeping the weeds out of it. Our portion of the project is for a desiccant. Other sites are doing a fungicide trial on it because there's just not a lot of registered fungicides or registered desiccants for canary seed because it is still kind of a boutique crop. There's not a lot of acres of it growing here in Western Canada. At best, there might be maybe 250,000 acres, and that's on a very, very good year. There's just not a lot of acres of this stuff growing out there, which means there's not a lot of approved herbicides or fungicides for it. Any questions? It responds very heavily to chlorine or chloride fertilizer. So we typically increase the potash because the potash fertilizer we use is potassium chloride. So it responds very heavily. You get a huge yield boost out of that chloride when you're putting it down with it. So we typically double the potash when we are planting canary seed, and we see huge benefits out of that. But yeah, that's our canary seed. 76, this is FP Genetics, and this is them showcasing their spring crop varieties. So this is a variety demonstration of the spring crops they have. So we have 4 spring crops here. We have their spring wheat, we have their barley, over there we have their peas, their dry peas, and behind us there we have oats. So these are the varieties they have typically for sale for farmers right now, and we're doing a demo of them, seeing how they perform in this area. So you should be able to see pretty good differences in height and lushness, especially on the oats. You can see that third one in there, that oat variety, very tall, very green, very leafy. That is a forage oat specifically just for livestock consumption. Whereas the one to the north of it, or to the right-hand side, that is one of the newer oat varieties that has been bred to be very short and have a high bushel weight or a high plump weight on the grain. So it's a lot easier to mill. And the one on the left-hand side of the tall one there, that is the traditional one that's kind of the embedded check right now. So we're looking at oats to see which ones are producing a shorter oat with a higher plump weight, because that's what farmers get paid on, is the bushel weight and the tonnage of the oats. They want to have better bushel weight, better plumpness, because the more plump that grain is, it's a lot easier to go through a place like grain millers. For the wheat here, we're seeing differences in height. Typically farmers moving forward want a shorter wheat, more of that energy going into filling the head versus actually having a tall plant. For the barley, this is the malt barley. So some of these malt barleys are, the newer versions here are measured against the check, which is this one right here. And they're looking for malt barleys that can have more nitrogen put down with it in order to have higher yield, but still maintain good malting quality without producing poor quality beer. And then our peas, which actually look pretty good this year, especially for all the rainfall. They are dry peas. Typically pulses like dry peas, lentils, chickpeas, they do not like high levels of rainfall or high levels of precipitation. They do not do well with that. So I'm stoked that they are still alive and standing as nicely as they are. We don't get to go to our broadleaf site, but they're about up to here on me at our broadleaf site. They look amazing this year. Yes, sir. Yeah, but even then you would think that they tend to fall down and lodge, and they tend to get a lot of disease in them, especially the raindrops. If you have a disease-infected plant, when that raindrop hits the plant and hits that disease area, it spreads it to all the neighboring plant with all the splatter. If you're doing fungicides, that helps, but it's only a temporary solve. It doesn't cure the plant, it's just preventative. But eventually that all washes away and gets degraded. But I'm just amazed they look as good as they do, because typically they look a lot rougher. All right, this is 374. This is our Grain Millers oat variety trial. So locally, Grain Millers is our local oat mill. We are one of the big oat producers in Canada, worldwide. We are number 1 for oat production, number 2. We're pretty high up there. Oats is a cool season crop, so it likes high rainfall and cool temperatures. So it's not gonna do the greatest this year when it's so boiling hot like this, but it loves water. So especially in this area, northern Saskatchewan, northern Alberta, and most of Manitoba, oats is a big crop, and we produce high tonnage and high quality oats. With that, the oat mills, they want to know which varieties are more susceptible or more preferable for them. And that's the point of this trial, to see which variety they like best for their mill, and those varieties change over time. Maybe some have a better milling quality, some produce better flour, some are maybe a lot more difficult to separate the glooms out from the hull and out from the starch or the endosperm. So that's what they're trying to find out. They want to see what these varieties are going to do here, and then they'll actually do milling runs with these varieties to see how well it goes through their mill. And then they will have a preferred list of varieties that they want farmers to grow. Because it's not just any oat variety they want ones that are easier for them to manage and have the desirable traits for them in order to process easier and faster. Looking at the varieties we have here, Fetch is one of the newer ones. Bayer is one of the newest ones we have. Arborg is a couple years old. Camden is probably our embedded check. Camden's been around for about a decade. And from the Oat Alliance is the OR, what is that, 534 or 536? Yeah, that's bred out of Saskatoon. But we do have a lot of oat processing in Saskatchewan, Alberta, Manitoba. We produce and grow quite a bit of oats and mill quite a bit of oats here. In the past, in my grandparents' generation, so your parents' grandparents' generation, a lot of the oats was grown in places like Minnesota and Wisconsin. And a lot of the oat mills are still there, but a lot of those acres have been replaced by corn and soybeans nowadays. So a lot of the oats we produce there is actually shipped down there to Cedar Rapids, Iowa, to the Quaker mill there and processed there. But a lot of the other milling is done here, is done at Portage la Prairie, is done at Rimbey, Alberta, and just north of Saskatoon at Warman, there's a giant oat mill there as well. Any questions? 71. This is our oilseed disease trial. This is sponsored by Saskatchewan Oilseeds. It is the Oilseed Commission that is now a combination of both what used to be Sask Flax and Sask Canola. They are now one entity. And we planted these ones here because we were looking for a disease nursery. Because last year this was a canola crop on this block. We're planting canola on again because last year we did the same thing for a certain block. And with that we had really good verticillium wilt disease infection. So we're having the Canola Council and Sask Ministry of Ag and Sask Oilseeds have all their agronomists come out here in September. And they're going to be running through here looking for verticillium wilt. That is one of the newer diseases we have for canola out here nowadays. And they want to train up their individuals, their agronomists, so they actually know what it looks like in the field. So when they go out to producers' fields, they can properly diagnose it and correctly diagnose it. For flax, we're looking for disease here as well, usually pasmo, powdery mildew, and take-all are the big 3 for flax. So far, the flax is looking pretty good. Canola's looking good, but it'll be riddled full of disease in a month's time. A good contrast is flax is one of the oldest crops we've been growing in Canada. Wheat, oats, barley, rye, flax, those came over with the settlers and with everybody on the boats 200 or 300 years ago. We've only been growing canola really in earnest for the last 60 years intensively. So canola is really a young crop for us, whereas flax is a very old crop. Okay, this is project number 363. This is improving hard red wheat standability without using plant growth regulators. Plant growth regulators is something new that we've had here for maybe the last decade in Canada. They've been approved in Europe and in the United States for many more years. The purpose behind a plant growth regulator is to limit the height of the plant and the biomass of the plant without affecting the yield of the grain. This trial is trying to do that with nitrogen seeding rate managements instead of using a plant growth regulator and planting timing. And you can see a couple of differences here. A little bit shorter, a little bit taller, probably a difference in fertility or difference in planting time. So if it's a taller variety, maybe it got more fertilizer, maybe it was planted a lot earlier, had more time to grow, versus the shorter stuff here, maybe it planted later and had less fertilizer behind it. PGRs are something that just got registered in Canada, like I said, about 10 years ago. They're more of a new product. There's not a lot of farmers comfortable with them yet. There's a very, very, very narrow window of application. If you miss that window of application, it actually detrimentally hurts your crop. It will actually delay maturity, so that's something you don't want to do. When we get to the very end of the block here, there's a wheat trial that has one block sprayed with the plant growth regulator, and you will see a large difference between the unsprayed versus the sprayed stuff. It'd be about a 6 to 8 inch difference right now. And that's the point of having a plant growth regulator. The downside is there's certain ones that work better for wheat and certain ones that work better for barley. And you do not want to miss your timing window, because if you miss your window, you're actually going to hurt your maturity of your crop. And that really is difficult for us to manage, because that pushes it later into the season, and that means snowfall, and nobody wants to combine in the snow. Any questions? All right, and this is project number 366. This is nitrogen management in malt barley, and this is being done in conjunction with 6 other AgriArm sites. This is led by Mitchell Japp at Sask Barley. He's their main agrologist. Funded by Sask Barley and by Adopt. The big point behind this one is trying to manage the nitrogen in these new malt barley varieties with seeding dates and with varying degrees of nitrogen applied. You can see the earlier planted stuff is usually quite a bit larger, where the later planted stuff is usually smaller, but we're getting good differentiation with that, and that's what we're looking for right here. With this, we'll have 2 different harvest times, and then the grain will be sent in for malt barley and malt testing to see if there's any quality differences between them. And then we can make recommendations to farmers like, hey, this variety you should plant earlier, or this variety you should plant later, and these are the ideal nitrogen levels you should put on it. For maltsters, there is the Canadian Barley Malt Score and the Malt Labs. They have a recommended list of malt barley varieties out there, and those varieties do not move very often on that list. Once it's on that list, that barley variety might stay there for 30 years. We just got rid of Metcalf, and that was only like 4 or 5 years ago, and that variety is pushing 30 years old already. Once maltsters get a variety that they like, they are loath to get rid of it. Once it is there, they like it, they want to keep it, and it's really hard to replace it. It's really hard to get enough data from here to convince the maltsters that, yeah, you should let farmers switch varieties to something like this instead. Because once they have one that they like and that they're used to malting, they are really, 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 really tough to get rid of it. Any questions?